I do want to reflect on the notes that I did last time. I'll mention this in class. But something I forgot to include on this page, which I will be discussing in class, which I touched on before, is free body diagrams. It shows up really late in the chapter, but we hit it a lot in this intro, and this is the free body diagram. So it will come up repeatedly throughout this chapter and be important to realize. So as a reminder, include this in your notes. A free body diagram is a diagram showing all forces acting on an object. And I underline on because I'll even do something extra, and I highlight on because we're going to get into Newton's third law, looking at how two different sets of forces interact, and that's important to understand that a free body diagram only shows the forces acting on one particular object. Okay, the second half of this chapter is talking about free fall and then falling with air resistance. So if you do a chapter walkthrough, what I want you to notice is 6.1 is free fall explained. We're going to look at heavy versus light objects. And then we're going to look at what happens when you free fall. Okay. So I will take my Cornell notes setup. Here we go. Okay, free fall explained. So if you notice, I skipped 6.5 talking about pressure. Feel free to go through and read it. It will not be counted for in the test. So we have learned that the acceleration due to gravity is 9.8 meters per second squared. That squared goes on the seconds for those of you who get tripped up with this. Okay, 9.8 meters per second squared. We've also rounded this to 10 meters per second squared. That's fine. Acceleration due to gravity. So any object that falls, no matter if it's an elephant, so the elephant's going to play a role here. Here's an elephant with his big ears, his big body, his tail, right? Okay, here's my elephant. Don't judge. It's terrible. And then there's a feather. Should have just done a bowling ball, but this is what pops up here. Okay, when these are both dropped, just like in the video, in lack with no air resistance, they both fall at an acceleration. Acceleration is 9.8 meters per second squared. That's acceleration. What I want you to realize is acceleration is equal to force divided by mass. Okay? So when you know this, if acceleration is always 9.8, if I set up this equation, if they're both equal to each other, the mass of the elephant is huge, right? Well, the mass of the feather is very small. Knowing that, you need to realize in order to balance out or equal each other, the force acting on the feather, the actual physical pull of the earth on the feather is pretty small, while the force on the elephant is pretty significant, right? That's the only way you can get this to end up equaling 10 meters per second squared in both situations. So the larger the object, the greater the mass, the greater pull the earth has on it, allowing it to fall at 9.8 meters per second. Okay? This is a hard concept to get. Bigger mass, the more the earth pulls. Lighter mass, and it kind of makes sense. How hard do you have to pull on an elephant to get it to accelerate horizontally, right? You have to pull pretty darn hard. While You don't have to pull very hard on a feather. Well, the Earth has that same deal. In order for both of these objects to accelerate at 9.8, the Earth is going to pull much harder on the elephant than it does on the feather. Okay? So what about the situation where you actually do have air resistance? So there's a good example on page 95 at the top. That kind of walks you through the math here. So I'm going to put a little note here. All freely falling objects fall with the same acceleration because the net force on objects is only its weight and the ratio of mass, weight to mass. Ratio to weight to mass is the same for all objects. Okay, it's important to note. So that ultimately that explanation is described up here in this picture. All right. So how about falling in air resistance? So if you notice, when you skydive, they make the time go faster by asking you to lay out on your belly. So you start going feet down, you just jump off the plane, and then, so here's you, going straight down. By mid-fall, they ask you to go like this and hold your arms out like that, right? This increases your surface area. So the increase in surface area means a decrease in speed. This is an inverse relationship, right? So the air resistance, an equation that's important to know is air resistance is proportional, not equal to, but proportional to speed times frontal area. Okay, that's kind of what we talked about here. Speed times frontal area. So the greater your surface area, the lower your speed. As one goes up, the other goes down. So terminal speed is when your acceleration is equal to 0. That means the amount of air resistance, all right, the force of air resistance and the force of gravity is equal, all right? This is terminal speed. You have these equations that kind of help you out. Force of gravity, if you don't know the force of gravity, you know that's mass times acceleration. So whatever the mass of the person times 9.8. That's your force of gravity, okay? And that means they're equal to each other. Now, The only difference between velocity is adding direction. You know, the difference between speed and velocity is just the direction of motion. So technically this actual drawing is terminal velocity, where you might have 50 newtons of air resistance versus 50 newtons of force, right? Those are equal to each other, so we might say this is a positive and this is a negative, but no direction is included, while the bottom half is direction. Okay, so that's kind of it. I guess I could have done this in the last set of notes, but quick practice, falling feather. I recommend you visit this physics classroom website. It kind of walked you through this. I really like the free fall and air resistance because this one's probably the hardest concept for people to get. So go ahead, go to this website. You can actually go to the physics classroom, click on tutorial and Newton's laws, and it's lesson 3. So Newton's laws, and then you scroll down to Newton's second law, free fall and air resistance. And once you're here, it walks you through the situation of the elephant versus the little dude. And it explains it and explains why it works and even includes an animation that shows these guys free falling, right? And it has a series of true-false questions, which would be beneficial for you to go through and answered, because those are similar to what you're going to find. Then there's a variety of other activities. So free fall and air resistance, we won't be doing double trouble. This is when there's 2 different things going on. I don't think. Yeah. So take a look at this. There's finding individual forces. This works with you through free fall. And yeah, this is a nice practice for free body diagrams. So I recommend that. Finding acceleration, the bigness. Okay, these are really helpful and useful for working through this. At this time, work through these questions to check your understanding. And hey, here's the homework for this night. Hopefully this helps. Good luck and have a good day.